All right, so now we have some atmospheric energy transfer. Um, so switch on over to the anticipation guide, number 5 and 6. So remember, all you're doing is true and false, just your best guess. It's going to be on the right-hand side. So 5, the condition of Earth's atmosphere at a particular time and place is also called the climate. Number 6, oxygen is the most abundant gas in our atmosphere. All right, so we're going to flip back to, and we said it was page 8, electromagnetic waves. So nearly all the energy in Earth's atmosphere comes from the sun. That's where we get our heat, our energy. This energy travels to the Earth as electromagnetic waves, which are waves classified according to wavelength or distance between the waves. So distance between the waves is like from here to here. That's the difference between the waves. But as you can see, this is an electromagnetic wave. It has the magnetic field, which is side to side, and then you have the electric field, which is up and down. All right, 2 different ways you can see the electromagnetic wave. See in terms. All right, so looking at this, on this side we have the longer wavelengths, and on this we have the shorter wavelengths, and you can see right here, just this little tiny little sliver, and it's a tiny one, is visible light. All right, so visible light includes all the colors you see in a rainbow. Different colors are the result of different wavelengths. So the type of wavelength, the bigger the wavelength, this side, the shorter this side, and all the other colors in between. For example, red has the longest wavelength and is the reason why it is on the outside of the rainbow, just like violet is on the inside of the rainbow. Okay, so we have some non-visible radiation. Like I told you, right here is just a tiny, tiny little sliver. But when we look at this side where you have the longer wavelengths, it is called the infrared side, or the infrared radiation. It has longer wavelengths than red. They're not visible, but you can feel these as heat. So here's infrared, microwave. You can feel some heat off that. That's how you get the microwave works, and then you've got radio waves. On the other end, however, we have the ultraviolet radiation. This UV, UVA, UVB, that's the stuff that you protect using sunscreen. Yes, the sun gives this off. We know this. We protect ourselves from it. But as you go farther, the smaller the wavelengths, the shorter the wavelengths, the more energy it gives off, the more destructive it can be. So it goes ultraviolet, X-rays, and then gamma rays. All right, so now we're going to talk about weather versus climate. Now, why am I doing this? It's involved with atmosphere. It's involved with the energy that is hitting the Earth. So let's look at weather versus climate. Weather is the condition of the Earth's atmosphere at a particular time and place. Like the weather right now, I'm looking out, it's kind of gray, kind of yucky looking. It might rain. That's the weather at this time today. Whereas you have climate. Climate is the weather conditions of a particular area over an extended period of time. So like ours is continental polar type, temperate climate, which means it changes from cold to warm, warm to cold. Or you could have something like the tropics. Tropics is a climate. It's in that area that is where, or the type of weather they typically have in that climate. All right, what is the composition of the air? Okay, so Earth's atmosphere is not all oxygen. It's actually made up of mostly nitrogen. That's the 78%. You've got oxygen, and then you've got other gases like carbon dioxide, methane, and so on. Okay, so why are we talking about atmosphere? We just looked at wavelengths and weather and climate. Why is atmosphere important on Earth? Well, if we didn't have it, we wouldn't be living on Earth. It makes Earth suitable for living things. It contains oxygen, the oxygen you breathe in, and other gases that you need to survive, because it's not just oxygen you need to survive. What else does it do? Well, living things need warmth and liquid water. We need to be able to drink water. You can't last very long without water. So that atmosphere traps energy from the sun, that heat from the sun, and it keeps most of Earth's surface warm because we can keep trapping that heat. Enough for water to go from a vapor to a liquid, or water to go from ice to a liquid. The atmosphere protects living things also from dangerous radiations like the UVA, UVB, UVC from the sun. And this is what I was talking about, UVA, UVB, and UVC. All right, so fun fact. Global warming is based on an increase of carbon dioxide. And you saw very, very, very tiny bit of carbon dioxide in our atmosphere. What we also have, and we talked about this in the previous one, is ozone. Ozone is part of the atmosphere which protects Earth from too much ultraviolet radiation. So in the stratosphere, you have the ozone. It protects us from that UVC. That's the really, really, really bad stuff. Most of the UVB, and it tries to do the UVA. That's why you have sunscreen. All right, I would write this stuff on the flip side, that blank sheet, some spot, write this in, because you may see it. All right, we're doing quiz time. This is quiz number 3. I would put atmospheric energy. 1, 2, 3, 4, 5. We're going to do this a little bit different. We're going to go over the question and then give the answer. All right. So the atmosphere provides all except which of the following? Is it keeping most of Earth's surface warm? Protects living things from radiations? Water exists as a liquid? Or global warming and cooling? So the atmosphere will provide all or do all except which of the following? You should have gotten D, global warming and cooling. Which gas makes up 21% of our Earth's atmosphere? Is it carbon dioxide, oxygen, argon, or nitrogen? You should have oxygen. Oxygen makes up that 21%. Nitrogen is the most. Which of the following is the most abundant gas in the atmosphere? Is it the mesosphere, the electromagnetic spectrum, oxygen, nitrogen, or methane? I'm hoping you got nitrogen. All right. What type of radiation has wavelengths that are shorter, smaller than visible light? This one, we're going to go to the ultraviolet side. And which color of the visible light has the longest wavelength? That one I'm hoping, so you have red, purple, yellow, or green. I'm hoping you guys go with the red. Red is it? All right, let's go back to the anticipation guide, 5 and 6. So 5, the condition of Earth's atmosphere at a particular time and place. This is called climate. True or false? This would be false. Remember, weather is the condition of Earth's atmosphere at a particular time and place, whereas climate has to do with the patterns over weather patterns over an extended period of time. For example, the tropics. The tropics are a type of climate. So this goes in that explain section. All right, number 6. Oxygen is the most abundant gas in our atmosphere. True or false? This one's false. Nitrogen, 78% of our atmosphere, while oxygen only does 21%. All right, so let's go to the summary. What is Earth's composition of what is the composition of Earth's atmosphere? Earth's atmosphere is composed of, what's it composed of? Remember, you have the troposphere, the mesosphere, the stratosphere, and the thermosphere. You could write those down. That's what it's composed of. How is it important to living things? It provides protection against UVA, UVB, or ultraviolet radiation. And the atmosphere provides energy. It traps the energy, which gives us heat, which also makes traps in the oxygen. And it also, because it traps in that heat, it provides liquid water. All right, in what forms does energy from the sun travel to the Earth? Energy from the sun travels to Earth in the form of electromagnetic waves, which are waves that are either short or long, have energy, provide visible light. All right, so that is it for the end of the notes. If you have any questions, please don't hesitate to ask, and I hope you guys have a great day.